Hi, everybody. This is Chris McHale. I am co-founder and CEO of SBK and Associates, and we're here for our third installment of vCAD use cases. And I'm here with two colleagues, Ed and Shahab. Would you guys go ahead and introduce yourselves?
Yeah, my name is Ed Chung. I'm Director of Engineering here at SBK. I make sure I work in operations, so I make sure that the things work and the systems are turned on, and that when Shahab here, all right, Shahab taught me about this new use case for vCAD, and I don't know, maybe Shahab, I'll let you introduce yourself next.
Okay, my name is Shahab Taharian. I'm the CAE manager at Stryker, and I deal with simulations on a daily basis.
All right, great. Okay. What would you say, this could be a personal question, and generally, do you think most of simulation, and that could be FEA, CFD, is most of it done on physical machines these days, or generally in the cloud? What's your take on that?
I believe it's generally a hybrid.
Hmm.
It's depending on the type of physics of the problem that you're defining. How much mesh cells do we have? Um, for larger problems, which involves a complex physics, we are using cloud or HPC computers to run these.
Okay, great. Is that what you think too, Ed? Just wondered if you had a different
Yeah, I
perspective.
didn't know that, right? But I think this is just it's been coming for a long time, and
Yeah.
and I think we're sort of maybe this is new, right, Shahab? Like we're hitting a tip over point of tip over point.
Okay.
Yep.
Yeah.
As it's becoming less, the cloud is becoming less expensive. People are leaning more towards the cloud rather than investing in the infrastructure.
Yeah. Okay. So since we're going to talk about cloud, obviously, during this conversation, for either of you, when you are doing simulation, running simulation in the cloud, setting that up, what are some of the challenges that you face or that people face doing that? You might want to talk about.
There have
Um,
been some challenges with configuration of Minerva configuration, right? I think a lot of times if you're getting a lot of different systems that talk to each other, the configuration can get confused when we're working with IT in particular, and then things don't work, right? I am an engineer. I just want things to work when I want them to work.
All right. How about you, Shahab? You,
I think my at least on a personal side, if I have a couple of simulations that I need to run simultaneously, if I have a deadline that is coming up, and I have a laptop or a desktop that I'm working on, and I don't have enough computational resources to run more cases, or I need to deliver something instead of waiting for simulation for 3 days to run, I want to run it in 7 hours or 5 hours. That's where the use cases come up that I can just fire up a cloud computing platform, and I can run the simulations and then close it and be done with it. That I don't have to buy a new computer just for a project, basically.
right. Right. So I know, Shahab, that you've been using vCAD for some, I think, CFD analysis, and I know you're still kind of new using it, but how has it made the running or setting up and running of simulation in the cloud easier for you?
I think the two biggest advantage of vCAD that I see compared to other products out there, it's number one, it's uh, it's the ease of use and it looks like a desktop. It looks like my own computer that I can just fire up at any point in time, and it can just come up. And when I'm done, if I close it, I'm done with it. So I'm exactly paying for something that I need, and when I don't need it, just done.
Yeah.
So that's one big advantage. And the other one is actually that it looks like a computer. So it's as if I'm opening up Ansys and running on my local machine. So that's a big advantage for me because I need to see the residuals, I need to see the flow field, I need to see the different scalar functions and so on. So with some of the cloud applications, you can only submit a batch file and you are not able to see and visualize as it solves the equations.
Oh, yeah.
So,
Yeah.
so I think these two make VCAD unique.
Okay. Do you have anything to add to that, Ed, or?
I think that's very complete, right? I think the making it easier to use, right? Training on how to use the system really, I don't want it to be that way, right? Here's Shahab, get 24 CPUs, go.
Yeah, yeah. It's funny how, especially these days, because we have so many tools and tools really that are available to us, but if it's just a little too difficult to use something or get onto it or access it, we just bail out, because it's just too hard. It just has to be that easy and that obvious, I think, even to engineers who are willing to deal with more tools, I think, than other
So
people.
true.
Yeah. I think that's kind of what we were trying to go for when we did this, is how do we make it as obvious and easy as possible.
And I think it can get integrated with already existing platforms such as Minerva application so it can integrate really well with that as well.
Yeah, because there may be other things that people are using.
Yeah.
Right. It's a funny thing because while everybody talks about, hey, I'm going to spin something up on the cloud, it's not hard to do, and yet there's just enough barriers and roadblocks to doing that it ends up being difficult even for the engineers. Sometimes it's even an access issue, right? But the ability to just pull something up on a browser and suddenly have really powerful resources available to you within a few seconds, I think that's helpful and saves people a lot of time. And then the money, like you mentioned, Shahab, because as soon as you shut it down, you're done. You're not spending any more money, right? Well, good. Is there anything else that you guys want to add? Any other comments or things that you might think might help other engineers out there that are wrestling with these same issues?
I think Shahab brought up a good point that I didn't even think about, right? It's silly. Our time is worth so much. I want to do the designing, right? I don't want to wait 25 hours. I don't want to queue 4 jobs, right, Shahab? Queue 3 jobs because I want 3 tests to go and then run it, Monday, Tuesday, Wednesday. Point of cloud is the scalability that I'm only paying for. Let me spin up my 3 computers, get it done real fast in parallel. Get back to it because, Shahab, how many times do you run a simulation, right? It's not just one simulation you're done. I assume you're trying, 5 millimeters and 10 millimeters and radius 3, and you want to compare the results. So do you do multiple simulations simultaneously often?
It depends on the case. Sometimes we utilize one of the examples of as an example of Ansys case, they have optimization tools that are available inside, so I don't have to manually update and run multiple cases, multiple windows at the same time. But those basically are running multiple simulations back to back without you visualizing it. So so that requires computational core and RAM and GPU. So all of those will help out if you have something that you can spin up and say, I need 32 cores, I need 24 cores, depending on your use case.
That's great.
When Ansys does those, does it integrate with SolidWorks? Right? Like, is it useful that vCAD can run SolidWorks and Ansys together? Not
Ansys generally I can't really speak on behalf of their products, but what my experience was that they are very integrated with different CAD applications such as Creo and SolidWorks. So files can be easily transferred to Ansys applications. So it's obviously easier for if you have your platform that has all the necessary tools inside. So you can, even if you have to change something, you can just change it within vCAD and just transfer the file inside. So yes, that can be also helpful.
Okay. Well, thanks, you guys. I really appreciate you joining and providing your time, especially to you, Shahab, our guest panel speaker, and wishing everybody a fruitful week. And thanks again, all.